In section 3-4, we're going to take a look at two triangles a little more closely. We're going to look at isosceles triangles and equilateral triangles and learn some fun facts about both of them. So first of all, just as a refresher, an equilateral triangle is a triangle with all sides congruent and all angles congruent, meaning that they are 60 degrees. And we found that out the past couple lessons. An isosceles triangle is a triangle with at least two congruent sides. And you can see in that picture, or that diagram of the isosceles triangle, there's a whole lot going on there. So we've sort of named what everything is referred to. So the isosceles triangle, the side that is not congruent to the other two sides, that's called the base. And the base has the base angles. Okay? The two sides of the triangle that are congruent are called the legs. And the angle that is created from the two legs is called the vertex angle. So we're going to refer to vertex angle, base angles, legs, bases throughout this lesson and then some of the theorems that we look at today. So the first theorem we're going to look at today is called the isosceles triangle theorem. And it says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So meaning if I have an isosceles triangle and my legs are the same length, that means these angles down here, the base angles, are also congruent to one another. So if I said this leg was 5, that means this one's 5. I told you that this left base angle was 40 degrees, you would automatically know that that right base angle is also 40 degrees. Okay? And then there's a converse to the isosceles triangle theorem, and converses are just saying the opposite, so it's switching the order. So it says this time if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if I have my triangle, my isosceles triangle, say I know that this is 65 degrees and this one is 65 degrees, then I don't care what those side measures are, but I know the sides opposite them. So those two sides, meaning this one and this one, they are going to be congruent. All right, so let's use those two facts to take a look at example 1. It says find the missing sides and angles if the perimeter is 70 feet. All right, so we have to find 3 sides, 3 angles. They gave me one side, gave me one angle, so that now cuts it down to 2 angles, 2 sides. All right, so we're going to go ahead and work with the angles first. Makes no difference. That's just what we'll start with. So let's take a look at our angles. So we know that all 3 angles of a triangle add up to 180. So if this vertex angle is 35 degrees, hey, this is an isosceles triangle. Let me get a brighter color. Because we know that these two sides are congruent, so since it's isosceles, we know the base angles are also congruent. So if we wanted to, we could call them each x. So then we would say 35 plus x is equal to 180. I'm going to add my 2x's to get 2x. I'm going to subtract 35 from both sides and get 145. So to get x, we are going to divide by 2, and we get 72.5 degrees each. Okay? So each base angle is 72.5 degrees. So we found our angles. Now we have to go through and try to find our sides. All right, so the hint they gave me is that the perimeter is 70 feet. So perimeter is where we add up all the sides. So I'm going to do A plus B plus C. They told me the perimeter is 70. They told me one of the sides is 20, but I can't have B and C. So let's take a look at those sides. And again, we can't forget, it's isosceles, which means both of the sides are the same. So I'm going to call them S, 4 sides, so S plus S. So if I subtract 20 from both sides, I get 50 equals 2S. divide both sides by 2, and we get the S is 25. So each side is 25 feet, and each base angle is 72.5 degrees. All right, first example finished. All right, let's take a look at example 2. It says find the value of x. So in this case, x is an angle. So we have to get our mindset into angles. All 3 angles of a triangle add up to 180. So they only gave me 2 though. But if I look again, it's an isosceles triangle. So these 2 sides are the same, meaning the base angles are also the same. So I'm going to get 2x plus x plus x equals 180. So I get 4x equals 180. If I divide 180 by 4, we get 45 degrees. All right, so those last 2 problems each had a triangle with them, which was very helpful. But if we look, example 3 and example 4 do not have triangles, so it might be helpful to draw one. So it says an isosceles triangle. So right away, I'm going to draw an isosceles triangle. Well, at least close enough to an isosceles triangle. Okay. I'm going to make sure it's isosceles by putting those 2 marks in there. All right, so the vertex angle is twice its congruent base angle. So that vertex angle is 2 times a base angle. Well, I don't know the base angle, so I'm going to call it x. So each base angle is x. Find the vertex angle. So this problem looks very similar to the last one. 2x plus x equals 180. So we get 4x equals 180, and we get that x is 45 again. But this time they didn't ask for x, and x is our base angle. They said find the vertex angle, and our vertex angle was 2x. So the vertex angle is 2 times 45, so it's 90 degrees. So I definitely did not draw my triangle correctly, but that is okay. So it's 90 degrees. All right, our last example for today. It says given that triangle ABC is isosceles, so we better draw triangle ABC. Make sure it's isosceles. So isosceles means 2 sides are equal. I better label it A, B, C. It says AB and BC are congruent. Well, thank goodness I drew the lines in the right spot. Now it's telling us that AB is 6x, A to C is x plus 15, and B to C is 2x plus 28. Find the area and the perimeter. All right. So to find the perimeter, I need to add up all the sides. Before I can add up all the sides, I need to figure out what x is. So the only thing I know is they have an algebraic expression representing the length of each side, but the left side and the right side are congruent. So I'm going to go ahead and set those 2 expressions equal to one another. So that's our first step. So we're going to do 6x equals 2x plus 28. So we get 4x is equal to 28, so x is equal to 7. So now we have to find the length of a side. So I'll do AB is equal to 6x, so 6 times 7. So AB is 42 units long, which means BC is 42 units long, but then AC is 7 plus 15, so that is 22 units long. All right, so now we have all 3 sides. Wonderful. That's going to help us find the area and perimeter. So third step, we'll do perimeter first. That's the easier one. So to find perimeter, we have to do 42 plus 42 plus 22. and we find that the perimeter is 106 units. All right, and now area. First thing I think of when I think of area, 1/2 base times height. And then I look at this picture and say, okay, I have my base. My base is, let me write this side lengths in different colors. So that's 22. Each of these are 42. I have my base, but I don't have my height. So we're going to scratch that area formula. Luckily, we do know another area formula. So it's S times S minus A times S minus B times S minus C, and S is half of the perimeter. So S is 106 divided by 2, which is 53. So we're going to do 53 times 53 minus 42 times 53 minus 42 times 53 minus 22. So we get 53 times 11 times 11 times 31. If I multiply all of that together, I get 198,803. And if I take the square root of that, we get that the area is approximately 445.87 units. All right, so take a moment. Try the next, 3 your turns. So there's only 3 your turns. And then check your work whenever you're finished.